Alright, here we have another example. Y equals 1/3 raised to the x minus 1 minus 4. So I got some transformations going in here. My parent function is y equals 1/3 to the x. So what has happened? We went down 4. And here x minus 1, I set that equal to 0 and solve. X minus 1 equals 0. I add 1 to either side. X equals 1. So I went to the positive, right 1. And I went down 4. Okay. This equation here is equivalent to that one. Again, 3 raised to the negative exponent. It's going to flip that over the fraction bar. And if you happen to see one that has a negative x, factor that out so you can see the negative, multiplying back to the x, and you can clearly see which way this is going, left or right, so that you can see what's going on there. Points on the graph. If I plug this into my calculator, I got to do so carefully. When I do, I'm going to get some points. I've got -1, 5, 0, -1, 1, -3, 2, -3.66 repeating, and 3, -3.88 repeating. When I went down 4, that's going to move my asymptote down from y equals 0 to y equals -4. So I can go ahead and draw that on my curve. 1, 2, 3, 4. All exponential curves should have an asymptote drawn, so we know what we're approaching. It's a defining feature. Plot your points. -1, 5. Go over -1. 1, 2, 3, 4, 5. 0, -1. 1, -3. 2, -3.6, and 3, -3.88. Draw a smooth curve best you can through your points, approaching your asymptote, but you're not touching it. Going back the other way, you're going to continue going all the way up to infinity. So is this growth or decay? Well, the base is a fraction. That makes that decay. Domain for all exponentials, negative infinity to positive infinity. There's the answer to the test question. The range, coming up from the bottom, first thing I see is the asymptote at -4. As I exit the graph, last thing I see is infinity. Can't touch infinity, can't touch an asymptote. X-intercept and y-intercept. Alright, well, the y-intercept I clearly see here at 0, -1. Okay, for our purposes here, my x-intercept is right in here. Right in here somewhere. Well, where is that? My best estimate for right here, I just have to estimate for right now, it's between 0 and 1. So we're going to estimate, say, approximately, we're looking at -0.5, 0. Okay, so approximately on that one. Increasing or decreasing behavior. As I read it from left to right, it is clearly going downhill. So it is a decreasing function. In behavior, as x approaches negative infinity, going left, the curve's going up, all the way up to infinity. As x goes to the right towards positive infinity, so I'm traveling to the right, the curve is flattening out on my asymptote, which is -4. Again, told you guys, in behavior for exponentials, one's always going to approach an asymptote. Another one's going to approach an infinity, whether it's positive or negative. Again, you got to look at the picture And these things could be written in different places depending on the picture you have. So look at the picture. Last example. Y equals a negative times 2 raised to the x plus 3. My parent function is y equals 2 to the x. Transformations to that. Well, this negative is a reflection. It reflects the x-axis. What that means is y equals 2 to the x. It graphs like this. And this one has been reflected, so it is going to graph like that. So our picture should look something like that red. I like the little 2-second graph, so I have an idea. Let's see if what I did is correct. The other thing that happened was the plus 3, so it went up 3, which moved my asymptote to y equals 3. So go ahead and draw on your asymptote. Get some points, plug them into your calculator carefully, get some points, and you should get a table looks something like this, where you've got negative 1, 2.5, 0, 2, 1, 1, 2, negative 1, 3, negative 5, you continue going, 4, negative 13, but you know we're off our graph there. It gives you an idea. Plot your points, negative 1, 2.5, so I'm going to go up 2.5. 0, 2, 1, 1, 2, negative 1, 3, 5. 1, 2, 3, 4, 5. Draw a nice smooth curve. Go 3 points. Make sure it kind of looks like a smooth curve and not a line. It's going to flatten out as I approach my asymptote. And it's going to keep going down to negative infinity as I go this way. My domain is the same, negative infinity to positive infinity for all exponentials. My range is restricted. Be careful on this one, guys. For range, start at your bottom, go up. Starting at the bottom, going up, first thing I see is an arrow pointing all the way down to negative infinity, so I'm going to start there. Remember, domain and range are always minimum, comma, maximum. Coming up, the last thing I see is I approach this asymptote at 3. I got to write that down. That's a barrier, and I can't touch it. Okay, my x-intercept is going to be somewhere between 1 and 2. Here we're going to say approximately 1.5, 0 would be my x-intercept. My y-intercept I can clearly see at 0, 2. I see it right here. I also see it right here. Almost done. Increasing or decreasing? Well, as I look at my function, it's clearly falling as I drop to the right. So that is a decreasing function. I forgot to do this one up here, guys. Is this growth, decay, or neither? Let's talk about that. According to my rules, when I look at it, we had 2 raised to the x. 2 is greater than 1, so it could be growth, but I reflected it. And as soon as I reflected my growth, it becomes a neither function. Okay, so this is neither growth nor decay because it was reflected. This does not look like a growth function like this blue function I sketched. This is neither. Same thing happens if I have decay in I reflected. So if I reflect it over the x-axis, it's always going to be a neither. Alright, very last thing, in behavior. As x approaches negative infinity, so I'm going left. As I go left, the curve approaches my asymptote, which is y equals 3. As x approaches positive infinity going to the right, the curve drops and falls to negative infinity. Again, one of them's approaching an asymptote, one of them's approaching infinity. You just have to read the graph to know which goes where. Hope this helps, guys.